Hello everyone. Now this problem is a fan favorite. This is from section 1.6 still, and it involves the use of the power property to resolve these radicals. So what we're going to want to do is isolate one of the radicals. We're going to need to utilize the power property, and then if we haven't cleared all of the radicals, we're going to want to do that same step again. So pretty much our goal is just to isolate the radicals. You'll only be able to do that one at a time, so let's just see how it goes. So I'm going to add the square root of x plus 1 to both sides. So we end up with the square root of 2x plus 3 equals 1 plus the square root of x plus 1. This is when we use the power property. So I'm going to square both sides. On the left-hand side, the radical and the exponent cancel. On the right-hand side, it could all be so simple, right? Where this could just be 1 squared plus x plus 1, but that is not the case. So this actually ends up being 1 times 1, which is 1, plus 1 times the square root of x plus 1, plus the square root of x plus 1 times 1, plus the square root of x plus 1 squared. So now we can cancel out this radical here, but we need to combine like terms for that radical. So let's update our problem. 2x plus 3 equals 1 plus 2 times the square root of x plus 1. And this is going to be plus x plus 1. Now I need to isolate my radical. The 1 and the 1 will combine. That will be 2. So just know I'm going to subtract 2 from both sides because there's a 1 and a 1 on the right-hand side. So I'm going to subtract 2 from the right. I'm also going to subtract x from the right. All right, let me move this 2 because it looks kind of confusing right now. I'll just move it over. Will it let me? It won't let me move it. It's all good. So what's going to end up happening on the right-hand side, those all cancel, that cancels, and we end up with x plus 1 equals 2 times the square root of x plus 1. Now at this point, we need to use the power property. Now there is an identity that can help you with this because you see you have 2 times the square root of x plus 1. If I have a times b and I square it, that's equal to a squared times b squared. All right, so coming on down, x squared plus x plus 1 equals 4 times the square root of x plus 1 squared. These cancel. So I end up with x squared plus 2x plus 1 equals 4 times x plus 1. You can already see where this is going to go. I'm going to distribute the 4 through both terms. 4x plus 4. The right-hand side, left-hand side is still x squared plus 2x plus 1. Subtract 4x from both sides. Subtract 4 from both sides. X squared minus 2x minus 3 equals 0. 2, 3, 1, 3. So this is going to be x minus 3x. So I have x squared plus x minus 3x minus 3 equals 0. X times x plus 1 x plus 1. Negative 3 times x plus 1 equals 0. Factor out an x plus 1. Left with an x minus 3. Proposed solutions. Proposed solutions. All right. And we need to check these. So it's negative 1 and 3. Now what I'm looking for here, my problem would be if the values I'm entering would give me negatives under the radicals. So, and also that we get a true statement. So let's take a look at negative 1 first. If we try negative 1, 2 times negative 1 plus 3 minus the square root of negative 1 plus 1 equals 1. This is 0, so that's gone. So I get the square root of 1 is equal to 1. Is that a true statement? Yes. Now what about 3? Because the 3 was our other solution, right? Right, so for 3, so we would have the square root of 2 times 3 plus 3 minus the square root of 3 plus 1 equals 1. Now 2 times 3 is 6, plus 3 is 9, minus the square root of 4 equals 1. This is 3 minus 2. That's also a true statement. So your solution set contains both of these. All right, so you have both negative 1 and 3. We'll walk through this one with the book. This one isn't as bad as it looks. So this time we actually are dealing with cube roots. All right, so cube roots are slightly, even index radicals and odd index radicals have different, I say odd index radicals are more flexible for their inputs, whereas evens are restrictive. So let's go ahead and walk through this. So just like with the other problems, we want to isolate the radicals. So if I just add the the cube root of x to both sides, I will isolate those radicals. And now I can use the power property here to cube both sides. And you can kind of see that's what they did here. They utilized the power property to eliminate this radical. I need to remind you that the cube root of x can be written as x to the power of 1/3. So when you cube this, remember the exponents will multiply. That is 1/3 times 3 over 1. That's how you're getting rid of that radical. Okay? So they cube both sides. They end up with 4x squared, which is just everything with the radicals eliminated. So 4x squared, negative 4x plus 1 equals x. You subtract x from both sides. And now this looks like something we can solve quadratically. Maybe not. Yeah, oh, no, we can. We can factor that. So we can get our proposed solutions here. When we plug these back in, they say that they're both valid. I will leave it up to you to plug those in. But I think by just kind of addressing the power property stuff, that can get you started in the right direction. We talked about these types of problems in our support class, but you look at that and you see x to the 3/5 power equals 27. Now, we need to raise both sides to the reciprocal power. So we have x to the 3/5, and that's going to be equal to 27. And I need to raise both sides to the power of 5/3. These cancel. I get x equals 27 to the power of 5/3. Now you can either take the cube root of 27 first and then raise that result to the 5th power, or you can take 27, raise it to the 5th power, and then take the cube root. Since I want to do some mental math, I'm going to cube root this first. So what mine's going to look like when I work it out, it's going to have the cube root of 27 raised to the 5th power. Now, cube root means we're looking for something that can be multiplied recursively 3 times. So 3 times 3, that's 2 times, that's 9. 9 times 3 is 27. That would be the 3 times there. All right. So 9 times 3 being 27. That means that the cube root of 27 is going to be 3. All right. You can also do this with your calculator. If I want to take the cube root of 27, I'm going to take the 27 and raise it to the power of 1/3. And I should get 3. Since I'm here, I can go ahead and raise 3 to the power of 5, and that's going to give me 243 for that solution. You can also raise 27 to the power of 5/3 here, because the point of this problem isn't whether or not you have to do this in your head. The point of the problem is, do you understand the power property? All right, so we're in a situation like this, and this is something I need to warn you about, because if you paid attention in the last example, likely what you are already planning to do is raise both sides to the power of 3/2, because you were paying attention. Now, anytime you utilize the power property and you have an even number in the denominator of the power you're raising it to, you need to add plus or minus. That's because what you're doing when you have this is you're taking the square root. Remember, the square root of x is equal to x raised to the power of 1/2. Anytime there's an even number in the denominator of your power property, you must add plus or minus. So we cancel out on the left-hand side, and we end up with x minus 4 equals, now we're going to add a plus or minus, and this is going to be that 16 to the power of 3/2. So pretty much you're taking the square, or you're taking the square root of 16, which is 4, and then you're raising 4 to the 3rd power. Now, 16, square root of 16 is 4. 4 to the 3rd power, well, I know 4 times 4 is 16. 16 times 4 is 64. Let me double check. Yes, 16 times 4 is 64. So now I add 4 to both sides. X equals 4 plus or minus 64. So you know those are going to give you 2 proposed solutions, which I will allow you to plug in and see if you get the correct answer. But you get 2 proposed solutions because you get x plus 64, which is 68. And then you get, 4 plus 64, which is 68. And you get 4 minus 64, which is negative 60. So I'm going to leave it up to you to check these. Okay, and that's going to be the end of this video. We're going to pick right back up with U substitution in the next video. Peace.